In the previous some lecture, we discussed about this non-conventional method, its advantage, disadvantage, and why we use non-conventional method over the conventional methods. Today we'll specifically see the first process, that is called the abrasive jet machining. Okay, so here in all this process means the things that is common that what you have to do, because if you go to the syllabus, different processes are there. Okay, so you have to first understand for the principle, their component, means what are the component of this machine, and their application of that thing, and then what we have to do, its advantage. रखवा दो ना सीधे सेकंड फ्लोर पे. So I was telling this in all this process, these are the common points that we have to discuss. So what is the principle of that method, component of that method, application. इसका लेक्चर चालू है ना, इसको मैग्नेट लगा दो, इसका मैग्नेट इसमें डोर बंद कर दो, मैग्नेट उसके ऊपर. Advantage. So that is the thing. Is all this process that you have to understand. It's how it works, advantage, disadvantage. These are the common points we will have to discuss. Okay. So we'll start with this abrasive jet machining. Okay. So first we see this, what is the meaning of this abrasive and jet. Jet we understand. Okay. So some kind of the water is coming from some kind of the nozzle. So it is having lots of kinetic energy speed. So it is called the jet. Same thing, something like the powder or abrasive metal kind of the thing. It is called the jet. Abrasive means it is a kind of the, we can say the inorganic material, and it is comparatively little bit hard compared to the other material. And normally they are used for a thing which is called the abrasion. Okay. So what is the meaning of the abrasion? Abrasion means what? When the two surfaces will rub. This is the, suppose this is the rough surface and this is the soft surface. Okay. So when there is a relative motion between this rough surface and this rough and hard also. So abrasive material means it is a rough and it is hard. So when they are rubbing to each other, so rough means something like this. So it will remove the material. Okay. It is kind of the removal of the material will take place. So this is called the abrasion. You know what will happen? Also understand this removal of this thing. Okay. So see here, lots of terminology we use. One terminology you heard about the wear. Okay. One similar thing you heard about the abrasion. See the difference among all these things. And one term we will use the erosion. Okay. Basically, all these three terms, whether it is called the wear, whether it is called the abrasion, whether it is called the erosion, This is related to the loss of material. Might be you studied in the, what we can say, the geography subject in the school. We hear the erosion of the, what we can say, the erosion of clay or erosion of sand. That you hear that thing. What is the erosion? Means what will happen when there is a flow of the river. The river will take some, what we can say, the dust, clay with it. So we call it the erosion. It is losing the sand, that thing. Whenever some flood will be there, it will take lots of clay with it. So that process is called the erosion. So here, this is called, here we also metal, we are using this term. What is the wear? Normally wear is what? You can see, let's two parts like gear. Gear are meshing to each other. So there is a relative motion between this part and this part. Because of this relative motion, with the time there is a loss of material will be there. So this is called a wear. Now there is lots of kind of the wear is there. We will not go in that much detail. But whenever there is a there is a relative motion between the two parts. And if you see in the mechanical engineering, you can find lots of such kind of the pairs which are having the relative motion. Gears is the most common example. If there is a shaft is rotating inside the bearing, so here also some relative motions are there. I am not talking about the rolling contact bearing, the sliding contact bearing. Okay, so here the shaft will rotate inside this bearing, so there is a relative motion. Cylinder and piston is there, so when it is doing up to and fro motion, so this piston cylinder having also relative motion. With the time, it will happen. Maybe you will face such kind of the problem. So there is a gap will be created between this piston and cylinder. Normally, we use the piston rings. So the piston rings will be changed. But it will happen wear. So wear is a means what we can say the very common kind of the phenomena. So we'll see in day-to-day life, wear and tear. Normally we use this word. Even tire, after some time the tire become like a flat. So we'll say the tire is wear out and now you have to change the tire. So that is that thing. Wear is a very common thing that is related to the loss of the material. But here the abrasion and erosion is a little bit different. Here also the loss of the material is there. But in the abrasion, use abrasive material, rough surface, move heavy relative motion to the soft surface, and this wear will take place. So if you see the grinding, anyway, so grinding is an example of this kind of the abrasive action. Erosion, what will happen? Normally erosion involves the fluid. Means if you take the example like suppose this is a pipe and this water is flowing, okay, water is flowing in the pipe, water any kind of the liquid, and this water also having some kind of the hard particles because it kind of the impurities, so they will strike on this pipe surface with a good velocity impact and it will remove some material. Okay, so this thing is called the erosion. It's from erosion. Somewhere in this abrasive jet machining, we are using the concept of the abrasion and erosion for normally all this phenomena, wear, abrasion, erosion. It is, you can say we consider it is like a negative phenomenon. We always try to reduce the wear, erosion, such kind of the thing. But here we are using this thing for our advantage, for making the holes, making some kind of the smooth surfaces, such kind of the thing. So this is the meaning of all this word. I hope this is clear. So you can easily differentiate between what is wear, what is abrasion, and what is erosion. All three are loss of material, but slightly there is a difference between all these three terms. Okay. One more thing. Erosion of metal, if I write this erosion of metal and search, okay, so most of the picture you are seeing, that is these are all the pictures, so they are showing the negative part of this, but if you see this picture, Okay. So in this picture, this particle are coming, striking on the surface, and they are making a kind of the small picture. यहाँ पे से nano fluid लिखा हुआ है, so you can say such kind of the thing, and it is making this kind. So this is the erosion. So this is the fluid with some kind of the nanoparticle is striking and making this kind of the loss of the material. So this is called the erosion. You see, remaining all the pictures basically related to corrosions and all these things. And if you see the abrasive material, so this is the diagram. So these are the, I think the grinding wheel, cutting wheels, these are all the things are there. And you can also see in the powder form, these are the abrasive materials. You can see the name also like this. This is the silicon carbide, most popular abrasive material. This is the grinding wheel. So it is made by the abrasive material using for the finishing things. Normally grinding wheel we also use after the finishing process of the welding process. Once we done the welding, so whatever the rough joint, they will become smooth by doing this grinding process. Here are lots of example of this abrasive material. Different abrasive materials are there. Okay. So depending on the things, it can be in this form also, in the powder form. So in the abrasive jet machine, obviously we are using such powder forms. So powder means what? Still it has some kind of the particle size. Powder means कोई भी powder भी होगा तो कहीं ना कहीं तो उसका कोई तो कोई particle size होता ही है. Particle size will be there. Like in the 3D printing, we also discuss about the powder bed. So powder means the very small particles of that metal. That is the metal powder. Okay. So now we come to our slide. Okay. So first we'll see the theoretical part, and then you again see that animation so that you can better understand. So abrasive jet machining is the process of impinging the high speed streams. Actually, in one lecture I was forget this term. That is the impinging. Impinging means what? This is your job, and this this will be the nozzle. Here is the nozzle. With the high speed, these abrasive particles in the powder form will strike on the this thing is called the impinging. Impinging the high speed stream of abrasive particle by high pressure gas. So actually the particle cannot move themselves. So we use a high pressure gas, normally air. Maybe depending on, we can also use the things like helium or inert gas. But in generally, because air is cheap and here is not that much problem of like the problem happen in the welding. So that will react and something will happen because there is not temperature is involved in this process. This is happening, we are doing the machining because of the mechanical action. So we are not having that much problem of the, if you are using the pure air, normal air. So compressed air is used on the work surface through a nozzle, and metal removal of course due to, here is that name. Metal removal क्यों होता है? Because of the erosion. This thing is called erosion caused by the high speed abrasive particle. So that is the definition of the AJM or abrasive jet machining. Some similar definition, some more in technical way it is written. A jet of inert gas. Here they are using the term inert gas, but both we use. Sometimes we use the inert gas, sometimes we use the air. Inert gas means what? We are more safe. It will not attack to the metal definitely. So gas like helium, either nitrogen kind of the gas. So a jet of inert gas consisting of very fine abrasive particle strike the workpiece at high velocity. Now that is important. As I said, this definition more technical. So this thing is given. What is the velocity? It is in the range of the 200 to 400 meter per second, resulting in material removal through chipping, erosive action. This erosive action has been employed for cutting. क्या क्या हम कर सकते हैं इससे? You can cut, you can clean, etching is there, polishing is there, and deburring will be there. this method of material removal is quite effective on hard. Okay, so where we use this process, we are not use this process for the soft material like aluminum. Normally, this process is used for the hard and brittle material. The reason behind this, इसका reason क्या है hard and brittle material क्यों use करते हैं? If you apply this process on the soft and ductile material, so what is the tendency of the soft and ductile material? If something will strike on it, so normally they change their shape. So you can have a dent on it, and but if the same thing you will apply on the hard surface, the surface is hard. So what will harden? Brittle. So what will happen when this particle will incide and impinging on it? So they will not change their shape. What will happen? They will break. The material will be removed because of this action. So if you are strike onto the soft and ductile, you will only, maybe you are not getting that much removal of the material, but you will get lots of, you can say, the irregularities of the surface. But on the hard surface, material will be removed. So hard and brittle materials, okay. What are the example of this material? Like glass, silicon, tungsten, which is very hard material, ceramics. So this kind of the material we use this thing, but not so effective on soft materials. So these are not effective on the soft material like aluminum or rubber, especially. So you cannot use this AJM material like aluminum or rubber. It can produce fine and complicated details on the parts made of very brittle material. So that is the overall, you can say in the one paragraph, lots of information is given here. Now, what are the part of this abrasive jet machining? So one gas supply is there. So gas supplies to the system for the operation. Here we can also use the compressed air instead of other gas. So depending on the process, we can go both. Either we use some specific gas, so you have to purchase that gas in that case. यदि आप कुछ helium या फिर nitrogen use कर रहे हो, argon use कर रहे हो, तो you have to purchase that cylinder. But if you are using the air, the normal compressor can compress, take the air from the atmosphere, and we can compress it. So obviously, using air is a cheaper option. Filter. So if you are using the air, so obviously you have to go for the filtering. You have to remove the dirt and all the things. So that thing will be there. Filters for removing the impurities. Pressure gauges are there. So you have to maintain some kind of the pressure. So pressure regulator, pressure gauges are used to maintain the desired pressure. It can change depending on the hardness of the material. The abrasive material can change, the pressure and velocity can also change. Okay, so regulator the same function. Mixing chamber इसमें होता है. So mixing chamber means what? Obviously, two things are there. One is gas, and one is the one. From one side, the gas is coming from the one side, the abrasive particles are coming. So you have to mix them in proper proportion. And then the nozzle. So when before the striking, it will pass through the nozzle. Nozzle will create the jet. Okay. This is made up of the hard material. The diameter of the nozzle is about 0.18 to the 0.8 mm. Again, it will depend on the different process, different nozzles can be used. Okay, this is just some kind of the line diagram, schematic diagram that you can say. So simple things you can, in the exam you can draw such kind of the diagram. The theoretical exam will be there because I have the another diagram also. Okay, so it is a little bit difficult to draw in the exam. This is a simple diagram. You can explain this kind of the block diagram. These are the relief wall, air filter here, pressure gauge, opening wall. Okay, here is the abrasive feeder. यहाँ पे mix chamber है. So means air is coming from this side. This is the hopper. Abrasive material is coming. You will mix this, and this is the mixture of the air and the abrasive particle will pass through this line. Here is the nozzle. You will maintain the pressure. What is the pressure? Here is one more important thing. This is called the standoff distance. What is the distance between the nozzle and this workpiece? So then it will strike this particle And then here will be some fixtures in your workpiece. So what action that you have to take, you have to make the holes or any other thing. And definitely, it will be guided also some kind of the control. यदि आपको होल बनाना है तो how it will move, it is also control is there. वो उसमें discussion नहीं है उसका. So that is the basic particle. If you see the next diagram, so it is more clear. This is the gas supply. So maybe you are using some specific gas. Here are the filters. Okay. And here is a mixture. यहाँ पे कोई चीज होती है कि vibrator होता है. So because it will vibrate, it will mix this thing, gas and this abrasive. And finally, this is the nozzle. Here one more thing, additional thing are given because this process means abrasive particle. So it should be in some kind of the some glass or something will be there. Means this particle either it will spread in your whatever the working area. So some kind of the such arrangement is there. So your this abrasive particle will be collected here. It will not spread around it. That is a simple thing. So two things are there. Compressed gas, supply of the abrasive, they are mixed here. A vibrator is there, it will vibrate this, and then this is the nozzle. Okay. Previous diagram में ये देखिए आप देखोगे तो 90 डिग्री दिया हुआ है यहाँ पे, but in this diagram they are showing this angle. So depending on the process, most of the time some angles are used, but if you have to make the whole, what is the process? आपको process आप क्या करने वाले उस पर डिपेंड करता है. But both things can be used. Either it can be 90 degree, either it can be having some angle, depending on the process. Okay. यहाँ थोड़ा सा exactly होता क्या है वहाँ पर वर्क पीस के ऊपर. So it is showing there. We are getting like gas plus abrasive particle velocity 150 to 300 meters per second. तो थोड़ा थोड़ा बुक के हिसाब से वेरी होता है. एक स्लाइड में 200 to 400 लिखा है, but here 150 to 300 meters per second दिया हुआ है. So book to book it can vary, but you can take yes. बुक के हिसाब से चले तो मिनिमम को 150 तक मिल जाए, मैक्सिमम 400 meters per second. But that is average range is 200 meters per second. That is the speed. Here this red dot means you can easily understand. ये क्या शो कर रहे हैं red dots? The abrasive particles, because here is the nozzle, but in this nozzle it is the air is there. तो जहाँ कुछ नहीं है वहाँ पे air आप मान लीजिए ये abrasive particle. So ये nozzle tip पे जो इसका internal diameter है ये 0.18 to 0.8 mm. फिर ये जो distance है, this is called the nozzle tip distance (NTD). stand off distance जो बोलते हैं. It can be 0.3 to 20 mm will be there. And then they are striking. और जब ये strike करेंगे, it is kind of the fracture will take place. This is called the erosion. और यहाँ से material remove हो जाएगा. So some more things are there. So important point, the filtered gas at a pressure of 2 to 8 kg per centimeter square is supplied to the mixing chamber containing abrasive. This is the pressure. जो हम बोलते हैं प्रेशराइज गैस होती है तो उसका ये प्रेशर होता है 2 to 8 kg पर सेंटीमीटर, किलोग्राम पर सेंटीमीटर. अभी अलग अलग यूनिट्स यूज किए जाते हैं. यदि हम अब जाते हो आपकी 2 व्हीलर्स में 4 व्हीलर्स में एयर भरवाने के लिए, तो देयर एनीवन कैन टेल मी व्हाट इज द यूनिट्स. जैसे आप बोलते हो ना कि फ्रंट व्हील और बैक व्हील में 30 का एयर भरवानी, 30-35. वो 30-35 एक्चुअली में यूनिट क्या है उसका? सभी ने कभी ना कभी तो किसी अपने 2 व्हीलर या 4 व्हीलर में एयर भरवाई होगी ना. इवन ट्यूबलेस टायर आल्सो रिक्वायर्ड द एयर. व्हाट इज द यूनिट ऑफ दैट एयर? The same for a car. So normally the pressure range is 30 to 35. So 30 to 35. हाँ?
बार्स में आता है क्या?
नहीं बाहर तो नहीं रहता है बेसिकली। अभी नेक्स्ट टाइम जब आप जाओ तो ध्यान देना, उसके जो भी उसका इंस्ट्रूमेंट होगा उस पर लिखा होता है इट इज PSI। वो जो यूनिट हम भरते हैं ना 30-35 PSI होता है। ओके,
Yes, sir.
तो इट इज होता है पाउंड पर स्क्वायर इंच। ये ब्रिटिश यूनिट है। तो अलग अलग हम जैसे बुक में कई बार पढ़ते थे कॉलिंग इट अ बार, 1 bar 2 bar atmospheric pressure. Here they have written this kgf per centimeter square, किलोग्राम फोर्स पर। तो ये भी एक तरह का FSI यूनिट है। बोथ आर नॉट दिस SI यूनिट, ये दोनों SI यूनिट नहीं है। SI यूनिट तो क्या है प्रेशर का, न्यूटन पर मीटर स्क्वायर। इन 10⁵ न्यूटन पर मीटर स्क्वायर इज 1 bar। So रफली है कुछ 1.01 समथिंग होता है, बट 10⁵ न्यूटन पर मीटर स्क्वायर इज कॉल्ड द 1 bar। This is the thing. So whenever you go to the next time, you can check. I will show you here. If I write, किसी भी कार का हम नाम डालते हैं। देखो यहाँ पे लिखा हुआ है। So this 35 PSI। तो जहाँ पे आप जो भी पेट्रोल पंप वगैरह पे होते हैं तो आप जो पैनल होता है जहाँ पे वो इंडिकेट करता है, या पे जो मैनुअल से भी जो चेक करता है ना प्रेशर, वो उसको चेक करता है ना, उसको एक से तो भरता है हवा, एक से वो चेक करता है। तो जो चेक करने वाला जो डिवाइस है उसको आप देखना, उस पर लिखा होता है PSI। नेक्स्ट टाइम यू
Yes, sir.
इफ यू राइट, किसी भी कार या टू व्हीलर का आप डालोगे गूगल पे आजकल तो मिल जाता है कि राइट प्रेशर कितना होना चाहिए, इट इज अ टायर प्रेशर इन नॉर्मल। ऑलवेज इट इज गिवन इन PSI, एटलीस्ट इन द इंडिया दैट प्रेशर इज यूज्ड इन PSI। जो उसके डिवाइस भी आते हैं ना PSI में ही आते हैं। तो जो मैनुअल्स भी होता है, कार का मैनुअल भी होगा ना, तो वो PSI में प्रेशर दिया होता है। तो different place we use a different kind of the unit, like in the when you study the thermodynamics, fluid mechanics, so you use the bar. In some cases you hear like AJM, so we are giving the value in the kgf per centimeter square. Okay, so this is the pressure. Like in the, if you study the boilers of pressure in the boiler, they will normally given the bar in the bar. So that will vibrate at the 50 hertz. So this is the again one value कि वो जो हमने बोला था वाइब्रेशन होता है तो कितनी फ्रीक्वेंसी पे वाइब्रेशन होता है। The abrasive gas mixture comes out from the nozzle at a velocity. So this point we already discussed. This velocity is, ये मिनट हो गया, it is second होना चाहिए, 150 to 300 meters per second. Abrasive particle of such, okay, this is the more one more important information. तो वो जो पार्टिकल साइज जो हम बोल रहे हैं वो कितने का होता है, ठीक है। तो नॉर्मली इट इज 10 माइक्रोन टू 50 माइक्रोन, मींस वो नैनो के रेंज में नहीं है। अब्रेसिव पार्टिकल्स का जो रेंज है ना वो माइक्रोन के रेंज में। तो 10 माइक्रोन टू 50 माइक्रोन, तो 50 माइक्रोन मींस काफी बड़ा, कंपेरेटिवली 5 टाइम बिगर इन द साइज। ओके, यहाँ वैसे दिया हुआ नहीं है। अब ये भी पॉइंट आता है कि वो कैसा होगा, सर्कुलर होगा या फिर लाइक ए कोनिकल शेप। तो ये भी डिपेंडिंग करता है कि आपको किस तरह का ऑपरेशन करना है। यू कैन आल्सो चूज अ पार्टिकल शेप। यदि ये कोनिकल या ट्रायंगुलर शेप है तो इट विल मेक मोर डैमेज मीन्स एक्शन ज्यादा हाई होगा इसका। ओके, सो द AGM नोजल इज बिग स्पेशल पार्ट है AGM नोजल। So the AGM nozzle is made of the tungsten carbide, okay, or sapphire. So these are the material. Nozzle is made of the either circular or rectangular cross section. Both cross section we can use, circular and rectangular. The nozzle pressure is generally maintained between 2 to 8.5 kgf centimeter square. The selection of abrasive depends upon the type of work material material removal rate. So these are some things that we use. So work material क्या है, soft है, hard है. So whatever the MRR you required, material removal rate. So I think in the starting lecture we discussed this point. When we show this table.
सर लैब में है कि मशीन रखी हुई?
नहीं ये एडवांस मशीन कोई भी हमारे पास जो है सिर्फ कन्वेंशनल मशीन्स हैं. मींस दे आर वेरी मींस दीज आर वेरी स्पेसिफिक पर्पस मशीन. मतलब आप कहीं जैसे बोला कि नॉर्मल वर्किंग में तो कहीं भी यूज होती नहीं है. सम स्पेशल पर्पस यदि आपका स्पेशल, जैसे हमने बोला कि obviously the cost will be high, and when you require the in the starting we discussed when we use this, when you require the extra surface finish or something like you have to make the diameter like 0.5 mm diameter, some special purpose जब होगा कोई भी मशीन यूज होती है. जैसे जनरली extremely smooth surface finish you require. So in Pune you will find these machines in some industry, but not in किसी भी इंजीनियरिंग कॉलेज में ये मशीन होती नहीं है नॉर्मली. मैक्स टू मैक्स यू विल फाइंड द 3D प्रिंटिंग मशीन इन सम कॉलेजेस, बट दिस इज आल्सो द एडवांस मशीनिंग. तो वो जो कि द कॉस्ट ऑफ द 3D प्रिंटर, द पॉलीमर वाला जो होता है FDM, द कॉस्ट इज लेस देन 1 lakh. So it is available in the college, but the cost of this machine are comparatively high. And again, if you purchase this machine, then you also require someone who is trained in that particular machine. Means they are not just like even lathe also, but the person who is running the lathe, he also done the ITI in that lathe machine. So likewise, if you are purchasing AJM, you require that AJM expert also. So it is means अभी ऐसे consider तो नहीं है. एक क्लास में हमने डिस्कस भी किया था कि if you want to interested in these machines, so after graduation and after diploma, there are some special institute like IGTR or something like this. Some famous institute in the Hyderabad. So 1 or 2 year course are there, postgraduate course, tool rooms course होते हैं. So there you can get the expertise in these machines. वहाँ practically भी आपको देखने को मिलता है वो machines. वहाँ पे उनके जो भी instructors भी होते हैं उस हिसाब से. बट ये बहुत स्पेसिफिक मशीन्स हैं, मतलब तो उसके चलाने के लिए भी इसे स्पेशल पर्सन ही चाहिए, मतलब दैट ट्रेनिंग उसको चाहिए वैसी. तो हियर वी वर डिस्कसिंग अबाउट दिस. ये सारे रेट यहाँ पे दिए हुए हमारे इस टेबल में. MRR मटेरियल रिमूवल रेट इसका कितना 0.8 होता है. सो डिपेंडिंग ऑन द MRR यू विल चूज व्हाट इज द मटेरियल. ओके. सो फिर जो इम्पोर्टेंट पार्ट है इसमें अब्रेसिव कौन कौन से यूज होते हैं? एल्यूमिनियम ऑक्साइड, सिलिकॉन कार्बाइड, ग्लास बीड्स, क्रश्ड ग्लास, सोडियम बाइकार्बोनेट, सम ऑफ द अब्रेसिव यूज्ड. यही अब्रेसिव हम वो जो ग्राइंडिंग व्हील है उसमें भी यही अब्रेसिव यूज होते हैं, बट हियर वी आर यूजिंग इन द पाउडर फॉर्म. सो अगेन डिपेंडिंग ऑन द थिंग्स, हार्डनेस ऑफ द मटेरियल रिमूवल रेट, वी कैन चूज दिस. Now, what are the applications? Special applications: cutting slots of thin section, contouring and drilling operations, producing shallow crevices and deburring. Deburring means burrs को remove करना. Producing intricate hole shapes in hard and brittle material. These are all the applications. Cleaning and polishing the plastic, nylon and Teflon component also. Frosting of the interior surface of glass tube. So these are all the application of this method. And ये last वाला भी ध्यान रखें, machining of super alloys. Super alloys means what? The alloys made by the nickel and copper, such kind of the things. Normally they are purposes for high temperature or you can say the high hardness. That alloys, उन alloy को भी तो आपको machining करना पड़ेगा ना इस shape में लाने के लिए. So this AGM kind of the things are used. What are the advantage? Already जो
Sir, can you explain the frosting? What's the meaning of frosting?
सर इसको ग्लास के लिए शायद स्पेशल टर्म यूज हुआ, जैसे यहाँ पे था ना कि डीबरिंग, मेटल में यूज होता है, तो ग्लास में भी कुछ उसको फिनिशिंग करना है तो वहाँ पे उसको फिर फ्रॉस्टिंग करते हैं इंटीरियर सरफेस ऑफ ग्लास पे। तो इफ यू मेक इट स्मूथ दैट सरफेस ग्लास सरफेस, दैट टर्म को वहाँ पे फिर फ्रॉस्टिंग यूज किया है। मतलब जैसे ईचिंग एक टर्म, ईचिंग ऑफ मार्किंग ऑफ ग्लास सिलेंडर्स। सो ईचिंग मतलब कैसा होता है कि काइंड ऑफ द केमिकल में ज्यादा वर्ड यूज किया था कि कुछ आपको स्पेशल कुछ ईच करना है, सरफेस रिलेटेड ही चीजें हैं। मतलब जैसे काफी सारे टर्म्स जैसे अब्रेशन हो गया, डीबरिंग तो क्या कॉमन है, बट ईचिंग भी जो टर्म है यहाँ पे, ईचिंग ऑफ मार्किंग, वही सरफेस रिलेटेड चीजें हैं। इंटरनली आप उसको क्लीन कर रहे हो तो उसको फ्रॉस्टिंग बोला गया वहाँ पे। ईचिंग मीन्स तो उस पर कुछ तो उसको मार्क किया है वहाँ पे, कुछ तो उसमें आपको ग्लास के ऊपर मार्किंग वगैरह करनी है तो उसको वहाँ पे ईचिंग कर वर्ड दिया है। तो डिफरेंट डिफरेंट प्रोसेस के लिए अलग वर्ड यूज किया, बेसिकली इट इज रिमूवल ऑफ द डेड मटेरियल। ओके, सो दीज आर द एडवांटेज। अब कुछ इसके डिसएडवांटेजेस भी हैं। ओके, लाइक मटेरियल रिमूवल रेट इज टू लो, सो प्रोसेस विल बी स्लो, पुअर मशीनिंग एक्यूरेसी, ओके, हाई नोजल वियर रेट, तो नोजल को भी हमको चेंज करना पड़ता है इसमें बार बार। सॉफ्ट मटेरियल कैन नॉट बी मशीन, दिस इज आल्सो वन ऑफ द डिसएडवांटेज। एडिशनल क्लीनिंग ऑफ वर्क surface is required due to the sticking of abrasive grains in softer material. Okay. So these are all the, we can say, the points of this abrasive material. In the next lecture we will also see its animation and the two more processes related to this similar kind of action. Similar means ये mechanical action है ना, ये जो action हो रहा है mechanical है, तो two more process that we'll discuss in the next lecture.